All right, now we're going to get into law curves. So the law curves command in NX allows us to create some really complex curves, really complex geometry, simply by putting in an equation. And this curve that can be made in 3D. So it's not just a 2D sketch like we've done. We can actually create a 3D line or curve and do a lot with it. The example that we're going to go over and the ones that are due for the homework are not super complex, but it can get complex pretty quickly. So we're going to do this spinning top as an example. First, we've created a scenario where someone found out that the ideal spinning top has a parabolic profile where the edge of the parabola is 6 millimeters from the inside, from the center axis, and 6 millimeters above the point that makes contact with the surface. It spans 6 millimeters, and it is defined by y equals x squared over 2. And so based off this information, we have determined that the equation for the parabola is y equals x squared over 2 minus 6. So it's going to move it. So it's going to move the parabola 6 inches or 6 millimeters from the center axis. And then our x is t times 6 minus 3. So remember, the 6 right here is our total span. And we see that the parabola spans 6 millimeters. So the parabola spans 6 millimeters, but it's shifted over 3 millimeters. So our starting point is right here. Now the parabola starts here and goes 6 millimeters. So we've got our t times 6 minus 3, and then the equation for our parabola. So let's go ahead and go to NX and start to solve this. So I've already opened up a new file. I'm in millimeters. And the first thing that I'm going to do is I want to open up the expressions. And I'm going to start making some of these expressions. First one I'll put in is t. And t is going to, or NX is going to solve the equation for all numbers between the 0 and the 1. So we're going to put in 1. And for most of these, really for all the ones that we're going to put in, we want to change our dimension to unitless. We're not really looking at a length. This is just a unitless number. And then we can do our x equation. But when we move this over to NX, it's not just going to be x, it's going to be xt. And that equation is going to be t times 6 minus 3. Again, a unitless dimension. Then we've got our parabola equation, which is y equals the x squared over 2 minus 6. But when we put it in, we're going to do yt. And then for our equation, we'll, instead of x, we're going to say xt. We can say xt squared. Do the caret for the square. We'll say divided by 2 minus 6. Again, we've got a unitless dimension here. And then we need to input one more parameter. So these law curves can be done in 3 dimensions, like we said. But for ours, or at least for this one here, it's only going to be 2D. We're not going to go into the third dimension. So we've defined the x, we've defined the y. we need to put in a parameter for z, and that's going to be zt. And we're just going to put in 0 because we're not moving. Keep that unitless as well, and we'll go ahead and hit OK. So to create our curve, we will go to Menu, Insert, Curve, and then Law Curve. And because of the way that we defined the parameters, it should automatically pop up. If not, go ahead and hit OK, and then go to View and Fit. Sometimes we either zoomed in too far to see it, or something else is going on. But as long as it's over here in the Part Navigator and you did the expressions correctly, just because you can't see it doesn't mean it's not there. So if you go up to Fit, you should be able to see it. If not, maybe something would happen with your equations. So we've got our parabola here, but it's just the curve. So what we need to do is create a sketch to complete this, and then we can revolve the shape and have our spinning top. So we can go to Sketch, and we can treat this just like any other curve. I can sketch on that XY plane. I'm going to make that my horizontal reference. Hit OK. And I'll come up here with profile and just kind of sketch this out. So I can, if you can't access the curve right here, make sure that you're in entire assembly or within work part only. If you're in just the sketch, you won't be able to access it. So make sure your filters are for entire part or work part. And I'm just going to rough this out. So this will be where the needle comes down to spin. And then we're going to come up past the arc right here, just to some distance, and I'll come over and then down to meet that parabola. And now we can start to dimension this. So we're told on the thing on canvas that the center of this arc is supposed to be 6 millimeters from the ground. So that's how I'm going to dimension this. I want from this point down here to the axis, from this horizontal axis, because that's where the center of the arc is, the center of the parabola. I want that to be 6 millimeters. And then up top, we can just do whatever we want. We can call that distance 7 millimeters. And we can say that should be 0.5. What we're looking for is our sketch to be fully defined. That's the most important thing. Get it finish. Oop, don't extrude this. We want to revolve it. Select our curves. Specify the axis that it's going to rotate around. And then we can hit OK. And now we've got that spinning top with that parabola. The one that's on canvas, I went in with an edge blend and just blended these transitions here. They look a little bit nicer. But that's how we can use law curves to create some complex geometry. Now, this one wasn't super complex, just parabola, but when we're told that a shape needs to have a certain profile, it might be easier to just put in the equation and have it create the 2D geometry for us, and then we can use the tools that we know to create that 3D geometry. All right, so real quick, let's look at part A of your assignment. So you got part A, part B. Part A is this nozzle. You are told the outer radius and inner radius. So this is the equation for the line here and this parabola. Now you can see that the outer radius is just a line and the inner radius is a parabola. And we're told that the x values are from -2 to 1. So the total span here is 3. Once we create the curves, we're going to revolve it around the x-axis. And then we'll find the volume. So we are actually going to have 2 yx equals. And so I'm going to do one of these and I'm going to act like it's the second one. So I'm going to act like we've already done one of the radii here. So I'll do this outer radius. We'll do that first. So I have just opened up another model here. And we're going to go to the expressions. We'll put in t, say that's a 1. We want that to be unitless. And then we have, again, we'll put in xt here, and the x values are from -2 to 1. We've got xt. This is t times 3. And then we start at -2. So we're going from -2 to 1. We want to start at -2. And we're going 3 spaces. So our span is 3. But we'll say 3. The span is 3. We start at -2. Change this to unitless. I'll go ahead and put in the ZT. That is going to be 0. And then I'm going to act like we've already done one of the YTs. So I can't just put in another YT. I would have to name it something different. So YT2. And the formula that we have for YT2, that is going to be the outer radius for me, is just -x plus 3. Remember, when we transition from our equations to nx, that x becomes xt. So it's going to be -xt plus 3. Again, we'll make this unitless, and I'll hit OK. And then when I go to put in the curve, I don't have a YT, I have a YT2. And we'll hit OK. Can't see it. Let's go to View Fit. And there it is. There is our line. So you are not bound . You're not bound by just the XT and the XT, or you're not bound by just the XT and the YT and the ZT. We name our expressions the XT, YT, ZT because that's the default in the law curve. So you could name this anything that you wanted as long as the name here matches the expression in the equations parameter. So then you could create another YT. The span is the same. And you could come in here and create another law curve. Just like when we did the spinning tool, we went to another sketch and we created that other geometry, and then we just revolved all the curves. So we can apply those same kind of concepts to the other two models that you have to make. Okay, so you have the nozzle and the plumb bob. So make those, You don't have to turn them in, but you do need to know how to create the log curves, and you have to understand the parameters that we went over. So the xt, the yt, understand the span and how we create the geometry using log curves. So you have to have a good understanding of that to be able to take the quiz.